All right, buddy. Welcome to this meeting of SMPTE Texas in partnership with Netgear AV. This is our network for broadcast webinar. Today, I have Trevor Van Dam, who is one of our art managers on the SMPTE board, and Alex Pendleton, who is with Netgear AV, and he'll be giving our presentation today. Down below in the chat, you just see a Q&A function and chat. So Trevor and I will be able to answer pass your questions through to Alex, and then just kind of answer any questions you may have. So yeah, Alex, the floor is yours.
Thank you. I appreciate the invite to be here with you guys and to talk about networking and networking products that we offer for AV and broadcast. And to give you a little bit of background of like where we have come from, Netgear has always been associated as the retail company. For those that just joined, my name is Alex Pendleton. I've been in Netgear for about 15 years. You can call me the ghost of Netgear past because I've seen all of the things that the company's done wrong, and I've seen all the things that they've done right. So I can definitely tell the history of where we've been and where we're going. And you know that the things that we made mistakes on kind of brought us to this industry. It brought us to the forefront of innovation for this system that a lot of you have had a chance to mess with. Some of you may have never built a SMPTE 2110 network or have been involved with the gotchas and the stop gaps, and hopefully some of the information that I'm going to break down today will help with that. We'll cover some multicast, some precision timing. We'll get into details on how our system works. We do have a little bit different system than say other manufacturers that you may have had preview to, and hopefully I can encourage you to give our systems a chance, an overview, and draw your own conclusions on just how impressive some of the stuff that we've been able to design and build for this industry is. I call this training SMPTE 2110 an IGMP Plus, which is one of our innovations, and what to kind of expect from IGMP Plus and what we see in networking for broadcast scenarios. And to jump into that fully, we've got to go back a little bit in time to 2015. So if you've all heard of Aptivision before, they were an Australian company. They were working on a chip that could do IP video, and there was an email sent by a manufacturer of switching chips sent to a lot of manufacturers, and those manufacturers, some of them responded, some of them didn't. We responded, and they were saying, hey, this IP video thing is going to take off eventually. It'd be good to get involved now. Well, when we evaluated the company, they were doing a 4K AV over IP, low latency, no compression, 10 gigabit, which is great for us. We had managed switches that were 10 gigabits that had high band, high capacity, and real solid capability that were actually being designed and being released in 2016, which was our M4300 series. They were probably the best enterprise platform Netgear had built at the time. They had all sorts of IT-specific features, and we were focused on the IT for them. We were going up against medium and small and large business cases. And we found that Aptivision was actually buying these products already. They were already purchasing our switches or planning to purchase our switches for their chips and doing a bundle system. So we decided to join their alliance, and that's when we joined the SCVOE Alliance in January of 2017. As a founding member of that alliance, as the only switch manufacturer involved. We started getting added to those 10 gigabit IP video networks, and Semtech purchased Aptivision, low latency, low level chipset manufacturer that was actually building the Blue River chip for Aptivision. And we founded a new technology from multicast technology. I'll get into depth on what that is here in a little bit, but we call it IGMP Plus. That happened in June of 2019. And that's about the time I started really focusing on this industry. I was dabbling in it in 2016, kind of heard about it, but I hadn't really looked into it. But around 2019 is right when I started really jumping in on it. And that's when we formed our Pro AV design team, which is a group that is focused on AV and broadcast industry right around June of 2019. Then in November of 2019, we came out with our first 100 gig capable switches, a 32 port 100 gig switch, a 48 port SFP28 or 25 gig with eight 100 gig uplinks, and we call that the M4500 series. These systems are good for SMPTE, but they're not the best. They are capable of preserving time. They're not capable of being Grandmaster. I'll get into depth on that a little bit later. So in January 2020, we certified with the #1 manufacturer at the time, Crestron, which was huge for us because they originally did not want us to be purchased with their products or interoperate with their products, and then they found that actually our system would work really, really well, and they decided to certify us, and later brought our M4250 series, which is really the unlocking of the AV over IP system. When you look at the system that we built there, we built hardware that was rack mountable forward and backward. We had a Kensington bolt down the center. We had lights in the front, ports in the back with the power supplies. We also had the software that went along with it, the first of its kind templatized deployment system that allowed you to pick which scenario you were going to do, whether it's Dante, NDI, SMPTE 2110, and put it into a profile. We launched without the lighting profile, but later came out with a lighting profile that ran the 2023 and the 2024 Super Bowl halftime shows. And then we launched our centralized management system, which we'll get into a little bit about. But if you want to learn more about it, it'd be a quick Google search, and you'll find out just as much information. We launched that in October 2022. After we launched the Engage, we launched our M4350 series in July of 2023. Now, these are to replace the M4300s because a lot of them had hardware limitations in the 10 gig side, some of them on the 1 gig side. Some of our wonderful integrators and customers experienced some of these hardware limitations. So we launched the M4350 series, which was a very important series because now we have a system that can be a PTP Grandmaster or a PTP boundary clock capable system for broadcast networks. We launched 2 switches with that series in our phase 2 release, which happened in January 2024, that are capable of doing the PTP Grandmaster or boundary clock for AES67 and SMPTE 2059. So you can imagine what was next on the horizon. Our focus on live production and broadcast is quite apparent. We want to make sure that we innovate significantly for these industries or these parts of the industry to build successful products and overall affect your network in a positive way. We don't want scenarios that have followed Netgear's enterprise class systems over the past, of where we didn't work with the customer when they had a problem or they hit a hurdle and we weren't there. I don't ever want that to happen. And my focus and my team's focus is this industry and the success of your networks, to the point where we go into engineering and say, hey, we need lights to be focused on the ports rather than the profile color just being in the interface and digitally in our web UI. We also want that to transpose to the ports so that when you want to plug in a SMPTE 2110 port or a Dante port, you can find that color rather than the port number. And we've done that on our latest phase 3 and 4. Each switch is being released with that multicolor capable profile to port colorization. We also have our first EtherCon switch that is also, all the new switches that we have are PTP Grandmaster. All our new M4300s are Grandmaster boundary clock capable for SMPTE 2110. This switch has a modular design. I'll get into more of that here in a little bit. We also have what I consider the next generation, I would say, of really good small, medium size, maybe even large size edge systems, or maybe enterprise edge systems in our new 100 gig 16 port 100 gig switch that is also Grandmaster capable, good aggregator, and we're bringing a lot more features online for this series, the M4350 series, since we have such an enterprise class platform. This has led us to celebrate that we have more than 500 plus broadcast and pro AV industry partners. There's pretty much everybody that you can do. Not all of them are on this picture, but this is some of them. And we find new ones every time we go to, You know, every time we go over to NAB or IBC or any of the broadcasts, we find new partners that want to do work with us, that have seen our technology work in other environments and have a strong request for our equipment to test in their environment, or we request their equipment to test in our environment. But we show collaboration as much as we can, because we want everybody's system to work. Our profile system, this is not all of the profiles, but I wanted to highlight a few that have been very, very helpful in the broadcast and AV world. Obviously, we have AVB. We've been an AVB provider for our M4250s and our M4350s since the start of those systems. We have the audio video SMPTE profile, which is also a hybrid profile for our non-Grandmaster and our non-boundary clock systems. We also have the Avid SX6L profile for AVB as well. This allows you to do a fully redundant system where you can flip between it, and there's no delay or drop in the audio as you switch from A or B. Also, ETC lighting, a very important profile that we worked on for about 1.5 years. My team focused meetings with them to get that profile out. They're very happy with it. They asked us to come and train their engineering team. Well, we're not going to Madison, Wisconsin in the winter. I'll tell you that much. A bit cold out there. So we told them summertime, no problem. Telos Alliance for AES 67 comm systems. And of course, we've been NDI supporter, adopter, provider as far as our networking hardware for quite some time. And our video NDI 5 and NDI 6 profile with allowing Dante and QSYS and AES 67 audio has been revered as the best in the business. And so we've been able to build a strong templatized system for our AV and broadcast systems. So the new phase 3 models, you have a smaller one, you have a middle-sized one, but you can see 8 and 24 2.5 gig ports with 10 gig and of course 25 gig uplinks. And then you have the 4340 platform at the bottom, which is a fiber version of our phase 2 switches that does Grandmaster clocking. This is that 16C that we have, the 100 gig fiber aggregation switch. Very powerful system, and is one of the big reasons why this year, 2026, we're really going to be getting involved significantly in larger and larger projects as we go forward. A strong backplane of non-blocking fabric and ultra quiet. One of the big hallmarks of the M4350s is they're super quiet and maintain their cool working condition without having extreme amount of fans. And then we have this one, which comes with the Neutrik locking connectors. We call it the Touring switch. It has a little modular line card at the uplink side, so you can have 25 gig fiber, or you can have copper 10 gig, and then you could also do either single mode or multi-mode. Get into what those are here in a little bit, of fiber patch connections. And the Neutrik connectors that you can purchase there for EtherCon to lock those power supplies. They're also fully serviceable in the field if you want. Also, we have some TAA compliance SKUs. All the new SKUs that we release are going to be in the TAA compliance in case that is a government installation, of course, and you can reach out to us about that. Quick, before we jump into the meat and potatoes here, our IGMP Plus, I'm going to get into detail how we got there just a little bit. We also have Auto Trunk, which is a way to basically build a system very quickly. The system will trunk one link. In Netgear world, we consider a single link between two switches a trunk. When you put more than one, so 2 or more links, up to 8 links between the switches, we call that a link aggregation or lag. So we have an automatic way of doing this, and we also have an automatic way of verifying that the other side is a Netgear switch versus another manufacturer switch. So we have these systems are very interoperable, as we will not go ahead and trunk automatically or auto lag to another system or another company system. So it's very interoperable in that case.
So we have a QoS platform that is, before we used to rely on the DSCP, which is the differentiated services code points, and this caused a conflict. There'd be queue, starvation in some cases. There would also be clashes between different systems, and so we've avoided that by the new system that kind of brings all of the different signals together to allow for a cohesive quality of service environment. So when you configure that, you got to ask yourself, what is a VLAN? Well, yes, if you're asking yourself, I know what VLAN is. It's a virtual local area network. I always do this as a trick question in our in-person trainings. It's a Netgear AV profile. So when you're doing the profile system that we have for our broadcasts and our environments, you deploy a profile. You're actually deploying a VLAN domain interface, so a broadcast domain that will allow for the communication to different devices through either layer 3 or layer 2. And this system is proven to really deploy quickly any system in this industry, AV and broadcast. So our SMPTE profile, which is the one we can deploy on any of our PTP, boundary clock, or grandmasters, we can easily go ahead and deploy that into a hybrid system as well. And that is deployable utilizing our Engage controller. So we can really deploy a large system, then we can go ahead and deploy SMPTE 2110, and then do hybrid AES 67 on the others to preserve the timing. I'll get into details about that. So, so multicast settings on a network switch, which I think is probably a good place to start. Instead of going through all these different acronyms, which we do in our in-person trainings, by the way. So if you see a integrator or a manufacturer have an in-person training, we do a 4-hour in-person training, me and my team, with a salesperson, territory manager in the region. They'll organize it in a location, and then we'll do the training, and we'll go into detail on all of these different items and get into it. But I want to also get into multicast settings specifically on the network switch, so that we can get into another really, really important piece of these broadcast networks to make that clear. So when you have a multicast scenario, right, you have a single stream. And in order to do multicast, you have to do some settings specifically on the switch, but the synchronization utilizing multicast across all of these systems allows you to dynamically change from this system to this system quickly and effectively without affecting the bandwidth of the network. So that one single stream from the media server continues and is basically on there. And if you ever want to see it, it's a great example to take like a Wireshark, plug it into your laptops, and watch a source stream come to your laptop. If there was a source device, encoder, decoder, something like this, and they sent UDP raw data frames without any actual data or content, you'll just see the container UDP file packets just coming to you via this multicast. They just get flooded to you. And the minute you add a source, now you start to see a payload start to build within that packet. So hexadecimal data starts to get added to the encoded packetization as it goes across. So, and this is due to the multicast feature set, allowing that stream to just be a container until you add file data to it. But really, there's no such thing as multicast in a network, to be truthful, unless you have a configuration such as IGMP. If you have no IGMP, multicast is treated just as a broadcast would, and it goes everywhere, uncontrolled, uncontained, unmanaged, and it just floods all ports all the time within that VLAN domain. And so you definitely need IGMP as a way to organize the multicast into actual stream data from sender to requester. The better the switch does IGMP, specifically IGMP snooping, the better the stream environment and the network health will be. And our system has been proven to do very, very well at layer 2 multicast IGMP. Our IGMP Plus is a layer 2 capable system, and IGMP snooping is it's like a linebacker. It's just right behind the line, waiting for a subscriber to come in. As soon as the subscriber comes in, it's like, oh, I got a subscriber. Do I have a source to this subscription? If no source, we're just going to hold streams where they're at. If there is a source, I'm going to send this over to the switch CPU, and I'm going to build a multicast router table, which is basically a ledger of the destination source MAC address to the source MAC address to the destination MAC address, and it bonds the port that interfaces that they're forwarding to, and they start streaming at that time. And this all happens in very, very quick succession. As soon as the CPU receives these 2 packets, and we know where those streams are to go, we build that into the router ledger. And then those streams start, and they last for about 10 minutes. Now, our default is 10 minutes. Others is different time, but you could also say 600 seconds. So 600 seconds, it starts to tick down. Okay, the stream will last for that amount of time. And in order to refresh it back up to its 600 seconds, you'll need a device to send out a query packet. Boom, sends out a query packet, and that courier packet is a real request. It's just who's listening to multicast still, and then the endpoint devices reply with their upstream communication. Say, hey, oh, I'm going to continue listening to the stream. When we tick down that 600 seconds and they respond to that query message, we refresh that back up to 600 seconds, and then we start ticking it down again until the next query interval. Now, in a Dante network, you'll see we shorten that to 2 times a minute. They want it every 30 seconds. And in more broadcast-centric systems, maybe you don't need it as long. Maybe you need a higher subscription interval, so maybe 3,000 seconds or something like this, and then you could have a query interval of around 120 seconds. So you have less communication of query packets, but the streams maintain. All right. So when we have 2 domains, now say I have streams that I have a media server in a different domain, VLAN 1 and VLAN 2. When I go ahead and try to send from VLAN 1 profile over to VLAN 2 profile, it won't make it in just standard IGMP. We have to move up to a new item, which is called PID, Protocol Independent Multicast. Our system supports sparse mode and dense mode. Difference between PIM's sparse mode is we will go ahead and collect the multicast groups procedurally, and as we find them, we build out the table. And then there's dense mode, which we build the table for all of them and prune the ones that are not being used. Okay, that's your differences between sparse and dense mode. Now, layer 3 multicast is a bit difficult to configure. All right, it's a big reason why Netgear has been so successful in the AV space. That's why a lot of people are using our Netgear AV line switches, is because our IGMP Plus mimics what we're doing with IP PIM in an environment that is layer 2 specifically. All right, so we build a layer 2 domain, but we also maintain the lack of upstream flooding from all of the different devices and all the different sources in the layer 2 domain, similar to how you would get if you were to isolate each individual stream group into different IP segments or IP broadcast segments, which is what you see a lot in current broadcasts. IGMP Plus can totally benefit a large-scale broadcast system by simply doing exactly what it's been designed to do, which is preventing the flood. We found it originally in 2019 when we did the Cooley Law Firm at 1 Hudson Yards in New York City. It was a big system, had an 8K screen in there. It was an SDVOE system, high band flooding. It used our older 96X, M4300 96X switch, which is sad because that system's gone now. We ran out of the chips. We sold out of the chips. We can't make any more. We used our 40 gig uplink card over here, and we had a fully hot and cold environment for the top floors of this system for all of this really high video going upstream and downstream. Well, as they were commissioning it, they got the 42nd, 43rd, and 44th floor. When they got to the 45th floor, they noticed that the saturation of multicast was so much that they couldn't get any of the streams to forward from any of these other floors. And the big reason why that was happening is not necessarily a problem with IGMP. IGMP was behaving appropriately. What was happening is all transmitter floods, and this is still true today for every other manufacturer other than Netgear when doing IGMP at layer 2 in a layer 2 domain. When you're flooding upstream to the leaf switches here, all the streams are stopped for the local ports, sure, but any uplink coming to a spine switch in a spine and leaf environment will forward, because the multicast is to the switches don't know, like leaf switch 1 doesn't know if there's a subscriber somewhere in leaf switch 2, so it sends all stream data upstream to the spine switch. And this is the way IGMP was designed without IGMP Plus's enhancements. So we went to work. Our engineers decided to build a system that would allow for our IGMP domain at layer 2 to operate similarly to the way PIM isolates the domain for you. Our scripts in IGMP Plus will isolate the domain for you so that the streams will only be forwarded if there is a subscriber throughout the network. And the way we did this is we made all of the switches aware of where all the multicast is and the forwarding port that for the subscriber multicast. And so any transmitter that is being streamed, all the tables are shared between the switches. So we can smart handle when a subscriber, say RX4 here, comes in and TX1 is to forward upstream, we can go ahead and forward just the transmitter 1 traffic to RX4, not all of the transmitter traffic. As soon as we loaded the firmware on the Cooley Law Firm that had our IGMP Plus enhancement, we didn't even know what we had. We didn't even know what we should call it. But it worked immediately. And then it worked for every installation that we did after that. And Netgear AV became a hallmark name for commercial, government, higher education installations. And now we're going to take that same system and offer it to broadcast. Can we do PIM if required? Absolutely. And if that is a requirement, if that's what you're used to, you should utilize PIM. And that will do exactly what our IGMP Plus enhancement will do. It'll remove the need for complex layer 3 configuration like PIM. It'll prevent that flooding. And it's ideal for multiple switch environments. And it's specific tailored to this industry specific level of flooding. There are some multicast groups that are required to be sent everywhere, and those ones need to go everywhere because they're used for discovery or timing or something like that. And those are the systems that we will essentially support. So the ones that don't necessarily adhere to the IGMP Plus scripting are our reserved multicast groups like timing and discovery and SSDP and stuff like that. When you're looking at the differences between AV broadcast design and IT design is mainly from stacking cores and stacking different edge switches. And while stacking is a great technology, it does kind of hamper the total uplink bandwidth between segments. For example, if I were to look at this redundant core stack over here, the M4350 16V 4C, it has two 100 gig links. Well, that means that technically, because I stacked them together, the max backplane bandwidth is 200 gigs. Now for IT, it's okay. That's probably fine. Probably don't need to worry too much about it. But for AV, that's not going to work, right? We need to maximize the non-blocking architecture as much as we can without compromising any of that feature set. Now, you can't do precision timing with the stack, so you have to remove the stack. And this links here, right here, will be a redundant link, sure, but it'll be used to be blocked by spanning tree. And IGMP Plus everywhere will maintain the consistency of the communication, so you have on-demand multicast wherever you need. If you look at the non-blocking architecture on this side, this was actually a design we did in Germany. It was a broadcast environment. Each one of these switches is a boundary clock capable switch. And then these switches are precision timing. This is what we call a dual tier MLAG. I'm going to get into detail on this configuration a little bit to show what needs to be built essentially to build this type of environment. But this system here is capable with IGMP Plus, and then MLAG is allowing the precision timing to preserve. This is a software like stack architecture, but it's not stacking, as in stacking doesn't allow for precision timing. Our target topologies for this 16C specifically is going to be broadcast environments, whether it be the 1 gig compressed or 10 gig systems. It has the capability to be the aggregator switch for these environments. And so when we're looking at design topologies, we really need to talk about fiber optics. And I do want to I just want to hammer home really fiber optics and how important they are. I noticed when I've been to some of these broadcast environments as a visit to see how they are being built, FiberStore has been one of those manufacturers that is added essentially to the list of purchase. And I just want to say these links are extremely important. The link between your network segments, if you have a spine and leaf, or if you have a redundant core, or even if you have a daisy chain, those links between the switches is really, really critical. You do not want them to be lacking quality. And when I was at Integrated Systems Europe in Barcelona, I went to the Matrox booth. They were connecting to the Green Hippo booth, doing SMPTE 2110 between the two booths. And they were having problems with our switches. So we ran over there. We were like, oh, is this a problem with switch? No, it was actually literally a problem with the fiber cable connecting to a really, really bad fiber module. So we replaced the module and we wiggled the cable just enough to get the light to work. And then we taped that thing and locked that cabinet and walked away. And that's how we got that signal to continue working for the rest of the show. Shout out to Paulo for being so willing to work with us there. But that's because it's so important. These two links, the small little bad patch cord could really be a problem, but also the fiber module. Now, I'm not here to tell you to buy Netgear branded modules. I don't care. I just want your system to work. So we really need to focus on quality modules as best you can, and multi-mode for your shorter distances. Multi-mode will work for your up to 850 meter length. It relies on the internal cladding, so the light comes in and bounces off the inside of the cable, which makes the cable more expensive, sure, but essentially the modules are a little bit less expensive because they don't need as powerful a laser. Single mode fiber is a little bit more powerful. It can go longer distances. For example, say like you've got a command center that's outside of a stadium and that's feeding into a stadium, and say like that's a good mile away. Well, that fiber connection from that command center to the stadium could totally run over single mode fiber, and that's going to be a really powerful module. It's going to be a powerful laser, and it's going to have the capability to reach those speeds. You could do 1 gig, 10 gig, SFP28, which is 25 gig, and then you have QSFP Plus, which is 40 gigs, so that's 410. But you also have 425s, which is 100. That's QSFP28. And we do have switches that will do SFP28 and QSFP28. And we do recommend utilizing some manufacturers that we have tested ourselves, and they have tested environments of AV and broadcast capable with their modules to ensure that your systems will maintain. And one of those is Flex Optics, German company. They can send to anywhere in the world. And they have very unique cable testing capabilities. Our hardware manufacturers gave them our hardware engineer, gave them a sign-off after visiting their facilities, and we bought all of their modules and tested them in our lab in San Jose against a lot of our AV and broadcast systems using like PTP simulator from Meinberg, stuff like that. Another one is Optics CA. Like I say, we have no vested interest in either of these companies. I just want your systems to work. And these guys have a whole section for compatible brands and they have one for Netgear. And we have what we call a 10G base T compliance. So that's if you were to equate it to a manufacturer, that's the Cisco compliance method. So we do follow that methodology for our multi-mode, single mode. So yes, you can, and these are going to be maybe a little bit more than FS, but they'll at least get you in a better position and more reliable, but even better. These have been tested in a lot of AV environments. So fiber optics between switches is really, really critical. And you can see when you're looking at the models, which one to build. When you see SR, you can think short range is what that's going to stand for, or shorter range. Then you have LR, which is going to be your multi-mode. It would be long reach or long range multi-mode. And then you have LR, which is your single mode. And that's going to be your 1310 nanometer, but up to 10 kilometers. So you can really reach a far distance, 6.5 miles or something like that in translation for those Freedom units out there that everybody likes to use. Okay, so another important thing of building these types of topologies for a multicast environment, okay, not for an IT environment, although this is an IT protocol spanning tree. It's also the bane of a lot of people's existence because I've been around a lot of these broadcast opportunities, and spanning tree has been a bad situation in many times. There's 4 main types that we see. It's traditional spanning tree, which very little amount of people use. They moved to rapid spanning tree. There were 5 steps in spanning tree, and rapid shortens them to 3, so it speeds that process of convergence up. Multiple spanning trees, so you can select different ports to be in a different region, or you can do RPVST, which is each network Netgear AV profile is its own spanning tree. When you connect 2 switches together, they automatically start sending what we call configuration BPDUs. These are bridge priority units that just tell the device which part of the tree it is in, whether it's spanning tree root or edge. If they are all the same, they're going to negotiate that and determine what is happening. If you have a link flap condition between these 2 switches, you'll have what they call a topology change notification. And if you see these strolling in the logs, then this is your problem. You might have a link between 2 switches that is really causing the problem. Our default bridge value is 32.768 because Netgear doesn't know what network they're going to be added to, or if it's an all Netgear network. So we don't want to go in and really affect change in a spanning tree network. So we start out with a bridge value that is coming in the configuration BPDU as 32.768. So let's take my topology here and say, like, I want to make sure that I have a spanning tree redundancy. Well, since I've defined the top root switch here as 0 bridge priority, and these edge switches as the next hop down, which we increment spanning tree hops as 4096 groups. So 0, 4096, 8192, 12250, so on and so forth. And all the way up to 64,440, all right? So when we do these hops and I make this redundant link here, as soon as I add this link, the configuration BPDU notices that the core, or the root, excuse me, is 0, and this connection's between 2 4096. So spanning tree immediately blocks the link as soon as I connect it. And that allows for, if these 4 links suddenly die, then this new link here becomes a new management link, and it'll unblock that as soon as it notices that this link is down, which is a huge benefit and a big reason why spanning tree is a good system to utilize in general, is that you can build a redundancy system without just by manipulating the bridge priorities and not having to rely on a single link. You can build a redundant topology without having that. Now the convergence time is in rapid spanning tree is between 4 and 5 seconds. That doesn't necessarily mean streams are dropping, because you remember you have multicast streaming, but it does take time for that new core or the new system to be rerouted for spanning tree. Now, maximum daisy chain is about 7, so you can go 7 levels deep in a topology, in a spanning tree topology, before spanning tree starts to really get too loose and it can't calculate all of those tree hops. And so we do recommend not daisy chaining switches in that type of scenario. We typically like to do spine and leaf or core topology, core edge topologies in AV. So usually in my hands-on, I like to do a little spanning tree test, all the information I gave you. If I connected all the switches out of the box in this way, which one is the root? And truthfully, when you do this, all systems, because of their configuration, BPDU says 32768, all of them become the root out of the gate. They have to have an election. This election process is 100% what you want to avoid in a live production environment. You never want to have an election process that takes place like that. So configuring your roots and your edges ahead of time is really, really critical. When it does this, it'll send out this source service address point, which is the point of origin MAC address, and the destination SSDP address. And one of these devices is going to become the root based off the lowest MAC address. And when it does this, it might be fine. You might have all your streams and everything's working, and then all of a sudden you add a new switch. They have a new segment of the network, a new part of the truck dock, something like that, and they plug it in, and then that's where you would run into that topology change notification BPDU, and we would start the whole negotiation process over. And this might be the lowest MAC, so it may become the new root. So you want to always try to avoid that just by configuring this 32768 on the switch you want and building your core environment first. All right, so spanning tree, it really gives, it isn't considered what I would say a high available, okay? It's good, it's okay, it works sometimes. It's not the best methodology for high available critical systems. So that's why MLAG is a much better system in order to build this. To establish it, you obviously have to have your cores. You need to have your 2 core switches. And in this case, I have my M4500 48X F8Cs. I go in, I set up a peer link between these 2 switches. And the peer link doesn't necessarily need to be multiple links. It could be 2 links. It could be redundant if you want it. It's going to leverage the same link aggregation protocol standard as 802.3 AD. Okay, so the communication between the 2 switches is going to maintain the communication between the 2 switches so that they have a communication. They share the tables. They're still independent switches, so they're managed independently, but the communication between them, if a control protocol is sent to this switch, it will subsequently be shared across this peer link to this secondary switch. And vice versa. Okay, so this is a great high available way to create a domain that is established once you create that peer link between the 2 switches, and you have a nice, comfortable, redundant system. Now, once I have the peer link, I need to tell, because I can still configure again LACP. This is part of the standard. It's always going to be there, but and auto lag is still turned on, of course. But I do want to be able to place a MLAG between the edge switches, and I need to configure them as MLAG local links, okay? So when I bring my edge switch in, I now have MLAG1 local link going to 1 switch core, and I have my MLAG1 local link going to another core. If I added a second edge switch, that would be MLAG2. The next one would be MLAG3. And each one gets its own MLAG off of the 2 pairs. And that way, if this link dies, this switch will immediately start using this link because it is in a link aggregate as well. There's no MLAG on this switch, so it has no idea that these 2 switches are in an MLAG. What they report back to this switch is that this is all 1 switch, and this is all in software, which means PTP and other really important control protocols are all shared across the peer link to preserve the communication, okay? So now our MLAG is complete. We have our core 1, we have our core 2, and we can subsequently go ahead and shut the system down on 1 core to simulate flipping to the other core and vice versa. And this is a high available environment for that level of redundancy. And you really benefit from having this system. Now, this is single tier MLAG, 1 MLAG domain. But what about double tier? You saw in one of my topologies, I had a double tier MLAG configuration. Well, this same concept exists for the MLAG domains. We still need our peer links between the 2 switches, but we also now need MLAG1 links to go between the both domains. Okay, so now I have MLAG peer domain 1 and I have MLAG peer domain 2. I build an MLAG 1 link in crisscross and up and down. And so I now have this redundant communication between all of the cores and all of them. Now, MLAG domain 1 does not share its table with MLAG domain 2. However, across this link will receive the same control protocols. So essentially, their tables are all shared together once they're in this domain. Then I go ahead and add my switches. Now, you can do this a couple of ways. You could say, I want one link here, one link here, one link here, one link here. You can totally do that. All right. It works the same way. You'll do a 4-port lag here, and you'll split all 4 ports here. You do have to do a careful delivery of path cost for spanning tree, which is an advanced configuration. And usually I would want my team to help you guys with that, but you could totally do something like that. What I see most of the time is they'll take one hemisphere of the MLAG pairs in both domains, and they'll do a link here and there, or they'll do a link here and there on the other hemisphere, but they'll maximize the peer link either way. So you can do literally either one. You could also do it on the bottom here. You could have 2 switches connected on this side. But once you configure the new link between the edge switches, that becomes MLAG 2. And the next one will be MLAG 3, and the next one will be MLAG 4, and so on and so forth. And that's how you can create a double tier MLAG domain that gives you a high available environment that if you lost one of the switches in the hemisphere, you would have a full redundant path to get back. We've used this in several different networks since 2019, since these switches came out. First one being the American Dream Mall, which is a large SDVoE environment, but it did a large bandwidth communication, which we needed to get to about 800 gigabit, close to 650 gigabit, I think. And so we did a double tier MLAG in order to facilitate that in a redundant fashion. And that's been working quite successfully. We also did it with a credit card company. This was done with the 4 links going around the switches. And of course, that worked out really, really well. Same concept. If you have questions on MLAG, please ask the question. We can get into it in the Q&A, or we can, of course, we can go ahead and talk about it offline. You can email us at proavdesign@netgear.com. Okay, so jumping to inter-VLAN routing and my explanation of how we do inter-VLAN routing, I want to explain that routing and VLAN routing on our switch architecture is always there. So the gateway, the layer 3 AV network gateway, is built in as soon as I apply a VLAN or a profile to the switch. So if I use my communication, because we have routing and internet VLAN routing, is enabled, when I try to communicate from 10.2, it'll go up layer 2 to switch A. It'll hit the gateway of 10.1 on VLAN 10. And it'll be going to that gateway because it's looking for somewhere on the internet. We'll say like CNN.com or something like that. Well, the default gateway for switch A is 99.1, which happens to be my default gateway router right here. And that's that green link right there. That's the connection from the gateway router. It's a different VLAN. It's VLAN 99. And my switch has an IP address, 99.99, in that VLAN. So there's a layer 2 communication here. There's a layer 2 communication here, but this connection between VLAN 10 and VLAN 99 is a layer 3, and it routes it. It'll route it just between the 2 VLANs. Then it goes up to the default gateway. The default gateway says, I will go ahead and do network address translation, convert that to a public IP, and it'll send it out to the internet, and it hits the internet, okay? Once it gets to its server on the internet, and it comes back to the default gateway, this is where you might have a problem. Many times we've had people come up to us and say, hey, you know what? Your layer 3 switch is not working like a layer 3. No, these are fully layer 3 managed switches. They have routing and VLAN routing out of the gate, and that is probably working to get out to the internet. It's once we come back. When we hit this, we're going to be looking for a destination on the NATed packet of VLAN 10. Well, if that switch, or excuse me, that router doesn't know where VLAN 10 is, then we are going to have to build a location for it to forward back to. In this example, if I'm going to send traffic back to VLAN 10, for traffic descent or 192.168.10.0, that's the entire group of VLAN 10, forward back to the VLAN interface for 99 on switch A. That way, switch A says, oh, I have VLAN 10 devices in my routing table. I can forward that back to the device. But it has to require configuration on the router that's interfacing with the internet in order to build that routing table back to the broadcaster AV network. You could do this on, we have a PR460X that we offer. It's got 10 gigabit LAN to WAN. It's a pretty powerful router. It's a standards-based firewall. It doesn't have any of the like intrusion detection or any of those security appliance stuff, but it does do stateful packet inspection and is a next-gen firewall and is a good go-between network segments. If you don't need a device to connect to another device in that network segment and you want to isolate the broadcast domain away, this is a perfect way of doing that and still having one interface to connect to, and then you can leverage port forwarding and other techniques to get to the LAN network of your design. All right. So that's my inner VLAN routing communication, because this is one of the things we see the most often. Just know that routing is enabled by default on these switches, and as long as you have each hop forwarding back from each hop and that they are aware of each other's tables, it's a way of completing the route as you go out. Okay, so now let's get into some really important essentials. Now that we have our topology understanding and we understand what we're going to expect from multicast, and we've got our tree configured in spanning tree, we've got our redundancy with MLAG. We now want to look at how we're going to preserve the timing of the communication, specifically for like lip sync. Your audio and video are going to be coming in on separate tracks. How do we sync those together so it looks perfect? Well, one early way that we started when Netgear first began to support PTP v1 and 2 is we have PTP v2 end-to-end transparent mode. Now that requires the switch to interact with the PTP packet. With PTP v1, which is what you'll see in the Dante network, you're not going to see the switch interact with those packets. You're going to see the sync and the follow, but you won't see the switch update any of that information. And the Grand Master clock is normally negotiated by the clock stratum of that packet. And so the Grand Master clock for whatever PTP v1 is will send the sync and the follow. The devices will forward back their delay request, and those devices will sync with their grandmaster. The switch is not going to involve itself in that communication. When we upgrade to PTP v2, now the switch is going to help the timing be more preserved as we go from the grandmaster and the follower clocks to see the delay requests. And delay requests, the amount of delay requests per second that you can handle is going to be a really important function of the switch, right? You want the switch to be able to really be able to pass traffic so you can scale your network to a really large quantity without having to worry about the timing not being preserved. End-to-end transparent mode is literally the best method. Transparent clock, I would say, is the best method of the IEEE 1588 suite in order to do this for PTP v2. And how this works on the switch. So this is my switch here. And if I ingress into the PHY is a little coalescer of the packets. It's the receiver of all the packets. It's the sender of all the packets. It gets them all in, and it doesn't process them per se. It just collects them and organizes them to be forwarded to the actual processor, which we call the MAC controller, okay? When it passes the PHY and it enters into the MAC controller, that's where the switch begins a clock called residence time. And as that packet moves from MAC to MAC, and it starts to leave the MAC and go out the egress PHY. Egress is network speak for leaving, and ingress is for coming in. When it egresses that PHY, we update that PTP v2 packet with a correction field update in nanoseconds. Now, this is also on wire transmission, so it's whenever that device produced the packet and forwarded over wire and then was processed within the switch, it's the difference between the epoch times, okay? So we read the epoch time coming in, we we update the difference in time leaving, and you'll see 4-digit nanoseconds on average, because we transmit in microseconds of latency, and sometimes 1.2, sometimes sub microseconds, so 0.2 or 0.4, something like that in some of our higher end switches, our higher end M4350s. So you'll see either a 3 or 4-digit number here in nanoseconds of the difference in time, so with the accounting for the wire transmission as well. And then you'll do that for each hop. So if you have 5 hops, then you're going to look at that nanoseconds, and that's how many. That's why daisy chaining is not a really good idea. The less hops, in my opinion, for PTP is better, because then you can maximize your timing and not have as large of a correction field. Now, there's some devices, I mean, there's some environments that's unavoidable. Big SMPTE plant, for example, that's going to be unavoidable. You're just going to have too many network segments. And the better you do this, like I say, the more delay requests you support, the better the system. But you're going to want transparent clock on the edge. Okay. Ordinary clocks coming into that transparent clock can sync with a boundary clock, like one of our switches can be the boundary, right? And then you can scale a larger environment with that TC ordinary clock. You can be a boundary clock for all those TC elements for all those devices. And then you can have the Grandmaster syncing with the boundary clock. That gives you a larger scale of reference clock and lesser time frame between the Grandmaster boundary clock to the ordinary clock. So that's less hops. And that gives you that kind of relief, if you will, off of the pressure that the Grandmaster has to maintain everybody's clock. In boundary clock and Grandmaster mode, we can support up to 850 plus clients. Okay, so we can do a pretty large scenario between the Grandmaster clock and the boundary clock, and then also the transparent clock. We can really build a large scale system, just being switch Grandmaster and switch boundary, and then we can even go to a large network with transparent clock through larger AES 67 or 2059 for those edge systems as well. So yeah, the sync packet is going to be what the boundary clock is going to consume. It's going to consume, and the boundary clock and Grandmaster will negotiate who's going to be the master and the boundary clock via the announce packet. Which brings us to our SMPTE 2110 standard and what switches we do provide for this standard that have this kind of capability. We now have the 3 phases. We have phase 2, January 2024, that are capable. We call them the OGs. And then we have the January 2025. This is the first switches we enabled with the LEDs. And we have the 4 switches that have LEDs on them. And now we also have the new ones, the aggregator and the touring, and those also have the LEDs as well, so that you can know what color things are plugged in. But every one of these new switches that we've just released over the last 2 years are all fully PTP Grandmaster and PTP boundary clock and PTP TC capable. The negotiation between the Grandmaster and the boundary clock goes through what we call the BMCA. Best Master Clock Algorithm. It elects a Grandmaster clock and it assigns the roles, whether it's master, follower, or passive port, which is like a redundant link between the switches. If we were to have a Grandmaster clock, we'll say like a Meinberg or some other Grandmaster clock out there, and that was connected to our boundary clock, we will have transparent clocks connected to that boundary clock. You typically don't want to do BC to BC. You're not able to determine what's happening in those 2 clocks. And also that you have to do a careful organization of the priorities. But if you did boundary to transparent, you can still build a really, really large system and maintain that system utilizing that. Now, this best master clock algorithm, okay, is going to start with the first comparable value, which is the Grandmaster priority 1 value. So typically, Grandmaster clocks that are built and designed specifically to be the Grandmaster of a network will actually have a low value by default, 10, maybe 15, something like that. Our boundary clock will start up high. We'll be at 127 or 128, okay? But you can fully adjust that and fully configure that down to 10, and this switch could be the master. for all of these systems, and if you have more, if you have 1200, 1400, and you can't utilize our switches as master, you can totally go with a PTP Grandmaster clock that is bigger, that can handle more, and then we would be the boundary off of that. And in either mode, Grandmaster or boundary, we can do 850 plus clients. The reason I say 850 plus is because the simulation computer that we were using to test our system, which is actually PTP simulation from Mindberg, the PC that we were using to run the simulator, it maxed out before our actual switch maxed out. So we're not 100% sure exactly the total number that we can support, but we were able to get up to 850. And just so you know, that processor was a 64-core processor. So we maxed out a 64-core processor on the simulator to be able to see our total max. One of the early designs that we were able to see ourselves in was the Panasonic Keros system, which had a QSFP 100 gig link to our 16V 4C. We had some studio cameras. One of them was a 12G SDI that was being converted from SDI to IP into SMPTE 2110 and 20 and 30 AES 67, and then it was coming in 25 gig for that stream uncompressed. And then that was being managed by the Keros, and we had a secondary system with a Grandmaster over there. And then we had some PTZ cameras, 3G PTZ. We also had an audio system. So these are like your large TV studio environments, and we are really in a system where we can deploy it very, very quickly. We don't have a very complex environment that really requires a whole lot of configuration. You deploy the profile. Once you get the profile, you start connecting your devices. You're on your way. And that's been proven time and time again. The next system that we see most connected, and one we just did at the NBA All-Star game, which is the Riedel comm system, or a ClearComm or RTS intercom system. These critical systems, one person from OSA told me she did a lot of integrations, and she said, comms. If you do comms really well, you could say that's the most important part of the show. And boy, would I agree with that. You really have to have good communication with all the show elements, and these systems are designed to be high reliability, redundant. And so the better we do our job on the network side, the better these systems can perform. And so we've joined a partnership with Riedel. We're interoperating with them very successfully. And we've had several large systems now that we can hang our hat on and say, hey, this worked really, really well with us as boundary clock or Grandmaster clock with transparent clock on the edges. The other edge case that we'll see is us as an edge switch, whether it be the smaller switches that we have in our first phases or in our new 100 gig switch. We see ourselves being a part of a large SMPTE environment. Could we be the core of that environment? I won't lie to you guys. No, not right now. Okay, don't put us at the core of a larger or enterprise class SMPTE design. Okay, but we can be that edge. We can maintain time. We can be a boundary clock for a Grandmaster clock. And we can manage smaller feeds of 3G SDI or 12G SDI coming in, and maintain that with NDI and Dante and all of the other signals that are being SRT, all of these other signals that are being added to the mix. We can do a very, very good job with our multicast platform in interoperability with other manufacturers. We have a few systems already that we've been involved in that had this specifically in the configuration. The next item is I wanted to show you guys our first environment where we were successful. In this system, the topology is such. This was in Japan. This is for a TV studio there, YTV. And it led to a partnership with Panasonic. We used their older KC100s. If you've ever heard this system, you probably heard it from a block away. It had the loudest fans I've ever heard in my life. The SPG 8000, a great guy over at Telestream, was with us at the Plug Fest for PTP in Ottawa, Canada, the IEEE Plug Fest. Great guy from Telestream, showed us all of his bells and whistles. They had one of their 8000As there. And then Astro using their converter boxes for SDI into SMPTE 2110 and then into our switch. Okay, so we had all this system coming in this reference design. It was almost as soon as we plugged it in. As soon as we connected all of the information, we loaded it up on to our screen, and we had really solid signal, no errors, no blips, nothing. Really good timing all the way through. And then Panasonic said we really should partner with Netgear going forward. This was fantastic, and it was a fantastic example of their capability and where they've come from. Being commercial AV, smaller enterprise, and now we're building systems that can support timing, and we're going to continue to innovate on that process. Okay, so we've talked about PTP, some designs that we've been able to complete. We've talked about MLAG, all the redundancy features, multicast. I hope this has all been beneficial. But there is one more element that we do get targeted at. Oh, you guys don't support this or you don't support that. And yes, right now, our system does not support the NMOS API. This is true. We cannot update to a device that is an orchestration device that updates its tables with health information from that switch. I agree. But in most NMOS environments, the switch has no NMOS capability as far as interacting with the API. And for the most part, we just need to make sure that the endpoint devices get to and from the registration device. The DNSSD configuration is there so that we upload our requests to the DNSSD server so that those endpoint devices can register their unique ID, and then you can go ahead and use NMOS as an orchestration platform to be able to send and receive feeds. So again, it comes down to doing multicast really, really well, making sure we do multicast really, really well, so that when you do go ahead and send the IGMP requests to the switch for the devices using NMOS, and those devices start to send their source stream into the switch, we manage that environment very, very well. And then to monitor the switch, you could leverage protocols that have been standardized for years, which are still very, very capable. Excuse me, which is SNMP is a great one. We offer full SNMP suite, a complete system that can monitor the system and the health and the multicast and the PoE usage and all of the different features of the system. But the better we send our peer-to-peer discovery over to each device, the healthier the system. Will we support NMOS API in the future? I don't. Netgear is a public company. I can't necessarily give you guys all of our roadmap data, but we'll work on it. We will continue to innovate in this category, and we will always want to build stuff that you, as an end user and an installer or a manufacturer, can utilize. We will never not look at a request. Every request that comes in the door, which there's been thousands over the last 5 years, we have either adopted into our topologies or we've looked at implementing eventually as fast as our engineering can go and prioritize them based on the request level and the requirement level. And as long as I'm at Netgear, I will do one thing. If we find something that is broken, we will fix it. That is one hallmark about Netgear is we do find things that we did wrong, and we will fix it. I can guarantee you that. We will resolve scenarios that we find out there in that field. And the NMOS API is something that we will continue to evaluate. We may look at investigate other products that could be an NMOS registration server or DNSSD server. We'll always continue to work on that as we go. Okay, so with that, guys, I hope we didn't lose anybody with the technical issues that we had here. But with that, I will take your questions, of course.
Yeah, no worries. Question is, with so many Ethernet ports and switches involved in creating an AV OIP network, would it be prudent to have a mirrored topology so software updates and upgrades could be applied to one while the other is online or updated?
Absolutely. And you can totally do that with an MLAG topology, right? And I would encourage having for -7 specifically the red and the blue. Okay, I would always want to do one system hardware that is its own contained and it's redundant, and then I would do another system that's also redundant and maintained, so you can switch -7 on the fly to a system that's fully operational as well. I would always have that. And in broadcast critical systems, this is proven time and time again to be a very capable system. But the cool thing about that is you just mirror. You mirror the same topology, right? And then you use -7 as a SMPTE 2110 protocol to flip between the two. Yep.
Cool. I think John has one more question. And he has, does Netgear support or are product compliant with MXL media exchange layer?
We haven't completely tested that in our environments yet. We are looking at that as a new media that will, as time goes on, we'll see how it gets developed. But we want to be fully not necessarily involved in like the API communication, but we do want to be able to support the transport communication. And of course, we'll look at full interoperability once we have more traction on what's happening with that environment.
And that's all the questions here in Q&A. But I got to I'm gonna throw at you, Alex.
Okay.
So I know in the chat we got a few folks from the House of Worship world. And and as you know, in the House of Worship world, you kind of already all in one person. You're the IT guy, you're the slides guy, you're the audio guy, you're the everything guy. And Trevor and I can relate to that. What is kind of like would you say are the things that we should take away from this presentation on these are things that you should either go look into in your own time or just things that you should have in the back of your head, especially when it comes to
well, the spanning tree portion, that one was probably the most important part. Let me switch the lights here. So spanning tree, when we're building a topology, it can be a very useful utility, or it can be a very detriment to your existence. Like it could be one of those protocols. And so you really you should focus on that primarily, and manage your environments with like the core and the edge, and try not to do too many hops. In some of the designs I've seen, and by the way, I would like to point out that Netgear AV and broadcast environments, they're so different from the IT traditional environments. And you can see this every time we get a network engineer that is from the IT background come into the AV world and try to institute the same principles and design ideas. It just causes chaos. And we really need to focus on like the MLAG as a redundance feature for high available environments for criticality. And then you use spanning tree as a way to maintain your tree links and preserve the topology health rather than a redundancy factor. Can you use it for redundancy? Absolutely. But it's best utilized to prevent network loops and to prevent the crash of the network via that network loop.
Cool. I think that was great. I think that's a great answer right there.
Thank you.
And then I see some other guys here. I see some of my old FM TV buddies here from time at A&M. I know in the radio and TV area, networking is pretty crucial, especially to control for systems. I know, like in the FM TV plant, you need to control. Automation systems talk to each other. Your transmitters need to talk to your monitoring system. What would be something that you will think it's for a system that is using switches more for control rather than for audio video transport? What would you say to institute the same VLAN structure on VLANs for different control systems, or kind of all one VLAN? What would be your approach for a broadcast network that is not 2110 but just for control network?
Yeah, perfect. That's a great question, because one thing I know about this industry specifically, after being in it for the past 5-6 years, is every topology and every network starts out with a dream and an idea. And that normally changes as it evolves. Things get modified. So I would always prepare the system to carry multicast signals. I'm not a huge fan of saying this is a control-only network, so we only need data profile without our multicast protections. Because remember what happens if you plug anything in the network that is a multicast device, a source, destination, whatever, and you plug that into a network that doesn't have the multicast management system, IGMP, you're going to flood that network, right? So you want to make absolute sure that those are there. So I would just use the video profile. I would, the video profile, just because IGMP is enabled, doesn't hamper your TCP control or your UDP monitoring or SNMP monitoring or SSDP discovery. None of that gets messed up utilizing just some protections for multicast. And you still should start the topology with an idea of less hops, of course, to maintain the communication. Like I say, in IT world, you can get away with multiple hops of stacks in different scenarios like that. But in the AV world, in my opinion, in the broadcast world, you should always maintain those multicast protections, and you should also limit the amount of hops that you're going, and also preserve the precision timing. Because what if you want to utilize that control network to test something? You could totally leverage that just by plugging it into an edge switch and seeing if you get communication that way.
Cool. Very good. Yeah. I think that's also the thing is, I think a lot of especially in the 2110 networks, it's like hard to, do we keep control on the 2110 network, or is it dedicated just purely to the traffic, or do you kind of move it over to its own proprietary, its own network? But yeah, correctly. I know a lot of times, like when you're working for like a university or within a non-broadcast company, where it's like they don't understand the workflows that we have in the broadcast side. It's like, oh, multicast accidentally went on the control network, now it's all down.
Yeah, and to comment on that, we have done probably about 10, I think, schools of journalism now. One of the more famous ones being Northwestern. That network's relatively large, 29 or so switches, I think, now, and he keeps adding to it, right? And that does SMPTE 2110. It does low end and high end NDI. It does some Dante in there. It's a kind of a hodgepodge of different experiences and different stuff that they're using in the broadcast booth. And they also simulate a desk working area that's outside, so they do a lot of simulation like that. And we've been able to be the cornerstone of those smaller studio networks because, you don't necessarily need a huge amount of video or a large amount of bandwidth. You don't need 400 gig per port uplinks or anything like that. So we've been able to facilitate that. And there's around probably 200 or so schools of journalism, maybe even more, that we're aware of, about 250, but there's probably more out there that still need to refresh those studios from older serial flows to new IP flows. And so we're here to support that 100%.
Cool. And I think a pretty good question. I think we about NDI workflows. So I've done, so my background is I work in TV trucks. I do all kinds of sports, entertainment, esports, all the above, whatever needs to be broadcast, I do it. And I know with esports, it's always, and NDI heavy. You have to pull NDI feeds from stream PCs. You're feeding NDI feeds to your encoders, streamers, all the above. Everything moves via NDI to and from the TV truck. And I know also in some like low level or like some entry level or budget friendly or just pro level broadcast, we want to use NDI. What would be like proper topology for setting up a just basic NDI network, would you say?
Yeah, so it goes back to having a core. Now, do you need the full MLAG level? No, because those are going to be 100 gig switches. Those are for large bandwidth. You can leverage a spanning tree redundant topology in that environment. And NDI, like a full NDI network is not going to be still a large amount of bandwidth, right? It's a very low bandwidth. So you can use our 1 gig edge M4250s, use like a 10 gig M40 350 core, so you have plenty of bandwidth to work with and adapt to. And in some cases, I can tell you, there is a stock exchange in New York right now that's using NDI HX over a Wi-Fi 7 network provided by Netgear. And there's 13 seats in that boardroom, okay? And each seat has a Surface Pro staring at that seat, and that's what gets brought in through NDI, upstream through the Wi-Fi into their vMix server and out to the rest of the world. And that's how they hold their board meetings, right? They're all very public and they're advertised that way. So each person speaking needs to be visible in those stream meetings, and they utilize NDI in order to do that. So NDI is extremely flexible from that perspective, and utilizing it over Wi-Fi is also really, really interesting from a adaptation to technology, considering NDI has a little bit of burstiness. The way it communicates over that Wi-Fi radio has to maintain the flow coming from the input out to the output. And so, you know, when you're building these types of technologies or NDI specifically into your network, it really comes down to the amount you're going to be doing. Also, as you know, with NDI Bridge, you have an internet capable system that, you know, you've got to take into account your internet service provider and what that's going to look like, and you know, the amount of sources that you can do with Bridge. And also, I wanted to add a little bit of element that I learned from going to one of the SVG summits in New York. It was prior to the NAB New York. Was an element of we had Adam Whitlock from ESPN, who does all their remote production. Now, look, ESPN is huge. They do all sorts of productions everywhere. ESPN The Ocho might have logging in upstate Minnesota in the summer. They got to get that to somebody's family, right? Somebody's family wants to see it if they're not there at the logging competition, right? And so he leveraged NDI. He leveraged full NDI, PTZ environments for the different angles. He also was talking about how they did paintball. They did the Professional Paintball World Cup or something like that. And so when they did that, that was all leveraged on the 3 different fields that they were filming through NDI. And these are the types of environments that you can do, smaller broadcasts and smaller level inputs for those communications. Can you leverage another signal like SRT for the internet rather than NDI Bridge? 100%. That is another great way to do it. But again, it comes down to the infrastructure you're going to be using out to the internet service provider. Of course, communication to them, and maybe a CDN depending on how much feed you're going to be sending them. But yeah, so these are all things that you would take into account for those types of environments. And to me, NDI is not going anywhere. It's going to only get bigger and more adopted in the broadcast space. So it's a very, very good system to utilize for those remote production type environments.
Yeah, good answer. And I see John has another question here in the chat, and it says, with so many software-based devices in the mix, is there a best practices plan of attack on doing quote-unquote system maintenance and updates/upgrades? For example, sort of a gym workout plan. If you have core, legs, arms, cardio, is there some best approach to doing VoIP system maintenance?
When we have our Engage software for our switch infrastructure to upgrade it, it'll automatically tell you, hey, there's an update if the work machine it's utilizing has an internet access. So when we do it, we'll normally tell you to start at the core, upgrade your cores first and then upgrade everything after that, or upgrade everything other than the switch you're connected to, and then you can upgrade that switch. But yeah, when it comes to those types of scenarios, you want something to at least tell you, hey, there's an upgraded version out there. Now, I will also caveat this, because I'm a huge believer, if it's working right now on the firmware you have on the network infrastructure, should you upgrade? And my answer is, if it's working right now and you're comfortable and you have things going, you better look at the release notes. Take a look at them. If there's something specific on there that you know you're going to need, or you have questions, you can always reach out to us. We'll illuminate for you. But I would leave it where it is, especially if you're in a production environment about to launch the NBA All-Star Game halftime show, or something massive that's going to be critical. I wouldn't maintain any. I would, going into it on the setup, yeah, but or on strike, I would upgrade to see if there's any upgrades. But I wouldn't necessarily do that before a show is about to start, because you have everything working, even if there was something in those release notes. So I'm a big proponent of, if you have it stable and you have it happy, leave those systems there, and then when the strike happens and you check upgrades, see if you can upgrade something. You have a few minutes of time to be able to deploy an upgrade or two. If not, then you can do it back at the shop. But yeah, definitely make sure that you are checking release notes before upgrade, especially if you had a working system prior.
And I think it's all the questions we see in the chat for today. But I think I would like to also emphasize on. There's one more actually. Oh, John says, "I'll give Alex a great answers for $1,000. Pat on the back for that one."
All right, thank you.
I think even the Great Resource Center, this is a SMPTE sponsored event, and yes, FYI, Netgear AV is a sponsor of SMPTE, and we thank you for that, Alex, for your time, and just for SMPTE. Netgear for being a sponsor of SMPTE, and also being a member of SMPTE does include perks of being able to do our courses, the virtual courses, for free online. You can do the SMPTE 2110 course, which is a pretty intensive. I think it took me like a week to 2 weeks to do it, but it's just goes through all that we talked about, -7, audio over IP, encapsulation, all of the above, and it's just a great resource to have. And also just great membership as well. There's a community of network of professionals here in the state of Texas, and for those watching from outside the state, thank you for joining. And Alex, you see we can reach out to you at proav@netgearav.com, right, for any more questions?
ProAV at Netgear.com. ProAV Design at Netgear.com. That's me and my team. We're a systems engineering team that is focused on this industry. And that also will go to all of our sales teams for the region. You can also reach out to your local, if you know them, regional salesperson, of course, and we'll be available no matter what to do what we can to answer questions, talk about designs, talk about scenarios, new technologies, send us cat memes. It's all available for us.
Yeah. And Alex, I know I worked with Alex and worked at Texas A&M. I worked with him on getting some network design plans, and their team is really great to work with. They're not a sales team per se, as they'll tell you, but they'll connect you to the people with the gear and just help you understand concepts and everything. So great resource to have, and just great people to know. I think that will. If anybody have any more questions, I see you getting some people are saying thank you, Alex. People saying thank you in the chat for just great presentation. And I think that'll be it. This presentation will be posted on our online and shared on SMPTE. And anything y'all need, thank you for joining, guys. This has been a great meeting of SMPTE Texas.